In the video introducing momentum, we saw an example of a baseball catcher catching a fast-moving baseball. We saw how the momentum of the baseball can change if the catcher applies a force to stop it. As the baseball is slowed down by the catcher's mitt, its velocity is reduced and therefore its momentum is reduced. The change in momentum is the difference between the final momentum and the initial momentum, and can be written as the mass multiplied by the change in velocity. This change in momentum is called impulse. Impulse is given the symbol of the capital letter I and has the same unit as momentum. Consider a Ferrari 550 Maranello driving with a speed of 50 km per hour to the right. Let's call this direction the positive direction, so that any vector pointing to the right will be positive. The car has a mass of 1,780 kilograms. What is the initial momentum of the car? The initial momentum of the car is the product of its mass and its initial velocity. Mass is 1,780 kilograms, and the initial velocity is 50 kilometers per hour, or 13.9 meters per second in SI units, given to three significant figures. As the car velocity vector points in the positive direction, then velocity will be a positive quantity. So the car's initial momentum is 24,700 kilograms meters per second, also given to three significant figures. The driver is busy checking his Facebook status on his mobile phone and doesn't see the brick wall in front of him. He drives straight into the brick wall at full speed and crashes into the wall, coming to a complete stop without any rebound. What is the momentum of the car after the collision? Since the car came to a complete stop, its final velocity is zero, so its final momentum is also zero. What then is the impulse of the car as a result of the collision? Impulse is a change in momentum, which is the final momentum minus the initial momentum. This gives us an impulse of minus 24,700 kilograms meters per second. The minus sign represents a negative change or a reduction in the momentum. So when the car drives into the wall applies a force against the car to stop it. According to Newton's second law, the force is a product of mass and acceleration. The average acceleration is equal to the change in velocity over time. We've just defined impulse as a change in momentum, or the product of the mass and the change in velocity. So force can be written as a change in momentum over the time taken. Instantaneous force is then the rate of change of momentum with respect to time. One of the important applications of this law is in car safety. Modern cars have crumble zones that reduce the force of the collision. So how does the crumble zone do this? When a car collides with a wall, its momentum is reduced as the wall brings the car to a stop from its initial speed. A change in momentum exists because the car was initially moving, then it comes to a stop. But the force needed to cause this change can be reduced by increasing the time during which the momentum changes. We can see this from transposing the force equation to have the change in momentum being equal to the product of the force and the duration. So if the duration is increased, then the force must be decreased in order to cause the same change in momentum. Airbags work in the same way to reduce the time it takes for the head to come to a stop from its initial speed. Now back to our careless Ferrari. When the car hits the wall with some momentum, the wall applies a force back against the car in the opposite direction in accordance with Newton's third law of action and reaction. Now consider that the collision lasted 0.2 of a second. What force does the wall apply to cause this change in momentum? Force is a rate of change in momentum. If the change in momentum is minus 24,700 kilograms meters per second and occurred over a duration of 0.2 seconds, then the force applied is minus 123,000 newtons, rounded to three significant figures. The negative sign shows that the force applied by the wall to the car points in the negative direction, or to the left, as we would expect if the force is opposing the momentum of the car, which points to the right or the positive direction. In summary, impulse is defined as a change in momentum, or the difference between the final momentum minus the initial momentum. The change in momentum of a mass is caused when a force is applied to the mass over a period of time. If the force is applied in the same direction as the direction of the mass's motion, then its momentum increases, causing the mass to accelerate. If the force is applied in the opposite direction as the direction of the mass's motion, then its momentum is decreased, causing the mass to decelerate.